leans out all the way.
All right, you ready?
And they still lean.
Yeah.
6 7/8, right? 7 1/4.
Yeah, but see, you can hop curbs with this thing.
What's the difference between 6 7/8 and 7 1/4?
3/8.
Inch and 3/8.
3/8.
3/8.
Inch and 3/8.
3/8. 6 7/8 to 7 1/4.
6 1/4
Oh, 6 1/4.
and 6 7/8.
That's totally different than what he said.
Yeah, what did you
7 1/8, right?
7
6
1/8 and 6 1/4?
6
1/4 is 7/8.
6 1/8 and 7 1/4.
6, 7/8.
That's inch and an eighth.
An inch and what?
An inch and 1/8.
Did you say 7 1/8
No, it's
and
inch
6
and a
1/4?
6 1/8 to 7 1/4.
No, no.
Right, so you're right. It's
Oh, he
inch
said
and an
6 1/8? I thought you said
6 1/8.
It's changed.
Yeah, it changed 4 times. What's the numbers?
But the
6 and what?
6 1/8.
Check it.
The last thing he said.
7 1/4.
I'm sorry. It's actually 5 5/8.
Wow. And what?
5 5/8.
I'm gonna write this down.
5 5/8 and 7 1/4.
Well, 5 5/8. There's another 3/8 there. 6 1/4.
2 inches minus 3/8.
Inch and 7/8. Should be.
5/8.
Inch and 5/8?
Inch and 5/8.
Okay, inch and 5/8.
What is it? I'll write it down and I'll figure it out.
Right here. Well, if it was 5 1/4 to 7
5
1/4 would be
1/4,
2.
and what was the other one?
It's 5 5/8 to 7 1/4. That would be
5
2
5/8.
inches.
Say 5 1/4, right?
2
And
inches
what was
minus
the top
3/8.
number?
Would be inch and 5/8.
7 1/4.
Yeah.
It's 5
So
1/4.
it's 2 inches. It's just a hair under 2 inches.
Or what? What are you figuring it out for?
7/8. There's an inch and 7/8 difference between the front and the back,
Okay.
I'll buy that.
right? Because it's
No,
7
but it's
1/4 and
5 5/8.
no 5 and did I say 5 5/8? I'm getting confused now.
It's higher in the front than the back.
I thought you said fried eggs.
That works.
5 1/2.
5 1/2. Now, come on.
Hey, listen. Here, check this. It's code. What does this say right here?
We're gonna be down in the forest soon.
We're at 5 1/2.
5 1/2. Over here?
Okay.
You're at 7 1/8.
5 1/2 to 7 1/8 is an inch and 5/8.
And this is going to be units and unit conversions, but this is part 1, just talking about units and why we actually use them in physics. Okay? So, first of all, units. What the heck is a unit and why do we use it? Well, first of all, it is a standard measurement. Okay? A meter for one person can't be different from a meter for another person. And here's where that really came into play. Way back in the day, I'm talking old France, okay? Really old France. The idea was that the foot, you know, what you think of as 12 inches, used to be dependent on the size of the king's foot, right? So here's the thing. You have one king, he dies, another one takes over, probably his son. You have a different sized foot. So now, instead of the doorway being 3 feet wide, it's now 3.5 feet wide. And that caused a whole bunch of problems and all that sort of thing. So this is the short, very abridged version of units, by the way. Then eventually, in France, what happens? French Revolution. The common man rises up to take over and overthrow the aristocrats, who are the rich people who were just taxing the common person and basically being in control of everything. So the common man rises up, and they rise up for the rights of the common person. Okay, and part of that, maybe it came out of that. I wouldn't say units were really high in their minds when they were thinking of revolting, but one of the things was, in France, in the 1790s, they created the new system of measurement, kind of in the same spirit, where it doesn't matter who you are, a foot is a foot, a meter is a meter, and that's when they created the metric system. Okay. So 1790s metric system. And that was really good. But then eventually in 1960, a bunch of scientists from different countries came together and they made Le Système International des Unités. I don't know if I pronounced that right at all. I would pretty much bet that I didn't. But we abbreviate it as SI, or Système International, which means the International System of Units. This means that all scientists use this system. And that's because if you have it the same for everybody, there's no arguments, there's no unit conversions, there's no problems like that, which still happen. Take the Hubble Space Telescope. It went up, and the American measurements were different from the metric measurements, and the mirror was misaligned, and they had to go back up a year later and correct for that, all because our units were not the same. So, anyway, 1960, that's the SI. That's what we're going to use, which is basically the metric system, just with a few tweaks. But I'm not going to get too much into that at all. But what you do need to understand is that with the SI system, we use the MKS flavor of it. And what we mean by that is M, K, and S stand for different units. M is for meters, K is for kilograms, and S is for seconds. That means the base units, the thing that we use most often for distance, okay, will be meters, okay? Okay, so what I was trying to say is that M is what we use for distance. We use meters whenever we talk about distance. It's the most common thing that we use. And when we're talking about mass, the most common one we use is kilograms. That's what we base everything off of. Not grams, but kilograms. And lastly, whenever we deal with time, we use seconds, which is kind of logical, but you kind of get the point there. Okay? That's what we mean by the flavors. Now, let's talk about the prefixes and stuff and some of the base units, some of the other ones. Okay? How does this work? Okay? Well, let's start off. Let's talk about, let's say, a meter. 1 meter is 1 meter long. That's about, well, I don't know if you can see this, but about this long. Okay? As long as a meter stick. See? Okay. So, if that's true, okay, a kilometer. So if we add the prefix to the base unit of meter, that means, well, what does kilo mean? Kilo means 1,000, and M is for meter. So what we're saying is that we have 1,000 of these. So 1,000 meters, which equals 1 kilometer. Okay? And it works another way here. A mega, if it's a megawatt is 1 million, one more zero, is 1 million watts. So 1 million watts is a megawatt. Okay? Now what you can do is draw a big dividing line here. Okay? Because this is where it goes from getting bigger to going smaller. For example, let's hop down to here, to millisecond. Okay? 1 millisecond is 1/1000th of a second. Okay? And that's what the 0.001 stands for. That's 1,000th of a second. Okay? So a millisecond is 1/1000th of a second. In other words, a second times 0.001. Okay? I'm not going to get into all of these. Just know that a decimeter is 1/10 of a meter. A centimeter is 1/100th of a meter, etc., etc. Let me say it one other way. In other words, there are 100 centimeters in 1 meter. Or there are 1,000 milliseconds in 1 second. Okay? There's, let's see, 1 million microseconds, 1 million of these in every 1 second. Okay? And that's really it for units. The only other thing I would tell you is to make sure that you write them in every single problem, because I count it. Because I don't know if you're telling me whether you have 50 bananas, 50 kilometers, 50 monkeys, 50 English teachers. I don't know. So you got to tell me, what are you counting? Okay?